Well, you're going to start with your 4 moles of iron oxide, and you're eventually going to end up at grams of iron. Good.
That makes sense.
Do you want one decimal point or?
One is probably fine. Gram per mole will always be gram per 1 mole. Because you're converting your moles of iron to grams of iron. Mole to gram will always be grams per 1 mole. Always grams. Anytime you do gram per mole, it's always gram per 1 mole.
I was almost right.
Almost right, yes. And it's like when you jump out of a plane, your parachute almost works. Or kind of like we eat in a restaurant and the cooks almost washed all the vegetables. Well, we almost washed the vegetables. Or you show up on payday and your manager almost paid you.
Then he was like, nope, I'm talking.
He did pretty good. He tried. I'm gonna call it good. He really tried. That's the question you should ask. You didn't get 440. You should say, damn it, what did I mess up?
I got the same answer, but I did 10 grams of FE and 2 moles of
No, I think yes. I would have to see your work. Yeah. 448?
I have 148.
I did that right.
448?
Yeah.
I did that right.
448. Okay. All right, let's jump in. So, gram to mole of limited use. Gram to gram is where we're going to be spending most of our time. And the system isn't really that different than what we've already been doing. It's just, instead of starting with moles of something, we're starting with grams of something. So, first exercise. How many grams of O2 would be produced with 16 grams of water? We're going to use the same equation as we have up here. Make our T-chart. What's going to be in the first box?
Starting information.
16 grams of water. H2O. And my goal is going to be grams of O2. Here's what I'm shooting for. The system still works like before, only now we need to get our grams of water into moles of water. So grams water to moles water, very similar to last time. The 16 came from the exercise. 16 grams of water. That just came from my given value for the exercise. How many grams of water are in 1 mole of water? 18. So in every 1 mole of water, there's 18. Thank goodness for the periodic table, such a great tool. Grams of water. Now I got moles of water. Can I convert from moles of water to grams of oxygen? No. No, I could not. I can only convert, the only way to change chemicals, the only way, is moles of A to moles of B. So I'm going to bring down my moles of H2O, and now I'm going to convert it to moles of oxygen. How do I fill this box? 2 to 1? Why do you say 2 to 1? 2 from here and 1 from here? Cool. I've got moles O2. Am I done? No. No, I'm not. I'm really close. The unit I have is moles O2, and the unit I want is grams of O2. This feels like something I should be able to do. Where would this conversion come from?
Periodic table.
Periodic table. Or Alexa. Say, Alexa, what is the mass of 1 mole of oxygen?
This might answer your question. Oxygen's atomic mass is 15.999 unified atomic mass units. Did that answer your question?
Mostly, because she doesn't realize it's molecules. So we know that 1 mole of O2 is not 16 or 15.999, it's 32. All right, and our math looks like this: 16 times 12. All right, 16 times 32. 16 times 32 divided by 18 times 2, and that's going to be the grams of O2 that we're going to need. 14? 14.2. All right. If your work looks like my work, give me a thumbs up. Okay. If you're ready to do one on your own, give me a thumbs up. If you have questions, put your hand up and wave it around. All right. So the next one's going to use the equations we've had previously. If you react 15 grams of hydrochloric acid with plenty of zinc, how many grams of zinc chloride will you make? So go ahead and work on this one on your own.
What do I have? You look like a boy. I was calling her a little boy last night. She got my hand all small. What? That is not. He said, I know it's not small, but.
Just the first section. We'll do the second question in a bit.
Wait, isn't the first one kind of like that one over there?
Yes.
stopping you? 30. I'm having a mobile small.
Wow. So
Hey, let me get out.
I put 36 as well.
You want 36 instead?
No.
Alright. Zinc chloride 135?
Yeah,
127. Wait, did I add wrong? I might have added wrong.
I got 135.
70, basically 71 and 50 is 66.
Oh. This. I looked at the wrong one.
Cliff ball, Chris ball. On the Kyrie Irving, Adam Spurs. You keep reaching, I keep teaching, you keep learning.
Okay, does your work look like my work?
Yes.
Wait, isn't it 16?
No.
Feels like just under 40.
28.
28.
Am I doing it
Point
wrong?
one
Oh, that's the second one.
28.1 grams of zinc chloride. Okay.
Wait, I thought we were supposed to do the first one.
We are. So, grams of hydrochloric acid. Take our hydrochloric acid and convert it to moles. Take our moles of hydrochloric acid and convert it to zinc chloride. Then take our moles of zinc chloride and convert to grams, and we have our grams. So how many grams of zinc chloride do
That's
we
that one. Yeah, I did the wrong one.
Okay. Give me a thumbs up if your work matched my work.
7.
Cool. Put your hand around and wave it around if you need a question.
Can I just wave at you?
Sure.
Okay.
Okay, so next, how much hydrogen would you make? Well, the great thing about this is what it's asking for is how much of the other product would you make?
So how much?
Well, we can repeat almost all this, right? All this we can just save, and all we really change is the product up there. Make sense?
Yeah.
So go ahead and do that. So our starting exercise is the same. We're starting with hydrochloric acid. We're getting into moles using the mole ratio. The only difference is now we're going to replace our product with hydrogen.
How much is H2?
Boom. He makes the best songs ever. 50K. Best show.
Because hydrogen is one each.
Okay, we're not
Do it again, do it again.
No, they're tuning forks sitting on top of wooden boxes. All right. Does your work match my work?
No,
Yes.
No. Okay. Yeah?
Yes, it does.
All right. Last one for you on your own. Here we go. Using your ratio of iron and aluminum again, if 77 grams of iron react with excess aluminum, how many grams of iron would you make? 77 grams of iron oxide, react with excess oxygen or excess aluminum. How much iron will you make?
What's that, sulfur?
Bow rosin.
What the... Does that make it magnetic?
Nope. Makes it vibrate.
Is that physics?
Is that thing hollow?
No.
I'll try it.
Okay. Hey, you can try it. Aluminum rod?
Oh,
Yeah.
Is that all that is?
Yeah. This aluminum rod. I actually bought some from. This is the one I originally got from Home Depot.
Mine makes noise.
Yeah, it's a noise-making rod.
If you get one
Happens to be exactly 1 yard. Not a meter. Yard.
get one that's one that's a half yard, like that.
That sounds so sick.
You didn't know you could buy musical instruments at Home Depot, did you?
Oh man, that's even worse. Yeah, right.
Okay.
Alright, now do it with that big one.
This one?
Just, oh. I just start playing Halo.
Shut up, Chris.
Iron oxide, molar mass?
127 grams.
27 grams of iron oxide.
Wait, no, let me double check that.
I thought it was like 160.
Yeah, it's 160.
He's not making any fun.
Alright, that's 160. Whoops. I'm sorry.
It lasted the whole day.